fact, even my parents have figured out I'm not a chemist. They know I don't work in boots. But the thing about chemists is at least they're easily identifiable. There's the whole white coat and lab specs and everything else. Whereas physicists, they're kind of harder to spot. I mean, there's the whole standing on mountains and waving and flicking your hair around. Or sitting in bunkers underneath the Swiss Alps. But actually, that's not what I do. And in fact, when I tell people that I'm a physicist, the most frequent response is, well, you don't look like a physicist. I'm never really sure how to respond, because I think that's supposed to be a compliment. I mean, I'm a fairly extrovert physicist. I got as far as talking to other people's shoes. But actually what they mean is, you're a girl. And yeah, there aren't that many female physicists, and that's actually quite awesome because it means there's no cues for the lose at conferences. So, having already insulted particle physicists and Brian Cox, I should probably explain what kind of physics I do. I do soft matter physics. That's exactly what it says. It's physics of matter which is soft. Squishy stuff. And a brilliant example of soft matter physics can be found in the form of Miss Katie Price. From the external coating of foundation and lip gloss to the internal structural enhancements, she is a living, breathing example of soft matter physics and everything that it entails. What I work on isn't quite Katie Price. I work on liquid crystals. You've got them in your phone screens, in your laptops, in your iPads. In fact, if I were to take a hammer and smash a hole in your new iPhone screen, a little bit of milky fluid would leak out. A bit like what happens if you make a hole in Katie Price. This is a liquid crystal, and I spent my PhD trying to solve a problem that I'm sure you'll be familiar with, that if you put your laptop screen at the wrong angle, the colours go funny. So, I spent 4 years studying how to stop this happening. And I found a solution. There's one catch. It only works between 51 and 52.1 degrees Celsius, which is not a lot of use in Scotland. I have had more successful research. My master's project was on chocolate, but it wasn't on any old chocolate. It was on chocolate that would heat up as you ate it. So as you ate the chocolate bar, it would get warm in your mouth. So sort of instant hot chocolate. And this works. It uses a sugar called xylitol, which you find in chewing gum and sugar-free peppermints. It's the stuff that means you have to have the warning saying, may cause laxative effects. You do have to eat a lot to get the laxative effects. Like over 10 grams, so it's usually quite safe. I had to test the master's project on myself. The heating up works brilliantly, it gets really warm, it's quite nice, you get sort of quite a rich hot chocolate. The only problem is, we never quite figured out how to get it to start reliably, or indeed, how to stop it starting completely spontaneously. So you have a rack of chocolate bars, and one of them would decide to get warm, which would mean it melted, and the others would get warm, and then all of a sudden you've got this big melted pile of goo on the floor. So this didn't get commercialized, which is a shame because I thought it was awesome. While I was learning about this project, I had to learn a lot about sweetness and about temperature and about how your body responds to sweet things which are hot. I learned very useful facts about why you must chill cheap white wine, because the colder something is, the less sweet it tastes, and the hotter something is, the sweeter it tastes. So all the really sweet white wines have to be really cold, otherwise they're just icky. Also learned about sweetness is that it can affect how you taste other things. So if you get somebody and give them a piece of chewing gum, and then make them blow into your mass spectrometer, which you've all got in your lab, obviously, then they, after a little while, will tell you that they can't taste the mint anymore. But if you look in your mass spectrometer, you can see that there's loads of the mint taste is still there. They're still breathing it out. There's still mint there, but they can't taste it. So what's going on? they've stopped being able to taste the mint. If you give them a drink of sugared water, you can taste the mint again. So it revives the flavour, which, well, that's kind of cool for chewing gum. And I was trying to think how this research should be applied, because we've all got to have applied research with impact now, right? Yes, there are faculty here. I was trying to think of another place where this would be applicable, and I couldn't. I was stuffed, and then I wandered down here and wandered past the machine in the ladies, and realised that it's probably applicable to flavoured condoms. But I haven't actually tried the experiment myself, so if anybody could try it and report back, I'd be really interested to know. So, soft matter physics also includes other substances which are soft. One of the other things we work on in our lab is caramel. And the problem with caramel is that it gets everywhere and it's sticky. So we're looking at the flow properties of it, and mostly it flows and it covers the lab bench in sticky goo. But at least if it's caramel, you vaguely know what it is. Another colleague, she works on deep heat or lube, and you don't want to get the two of them confused. Thank you very much.